Okay. This is the ramp PID adjustment. This is different than the curve test because we're not cycling between two values. We are going to ramp between two values. The ramp test PID adjustment differs from the curve test in that it doesn't cycle back and forth between two values. The ramp test will actually sweep between two values of speed. In this case, we're going to start at 2400 RPM and ramp down to 1000 RPM. What the graph will show with the blue line is the ideal system response. The graph will show a diagonal line from 2400 RPM down to 1000 RPM. The red line is your system response. Your goal is to make the red line follow the blue line for the majority of the sweep. To initially start, we want to put some value in the P control and some value in the I control, or else the system will not respond at all. Our P scale starts at the lowest value, A. Our I scale at the lowest value, A also. The motor is the DC motor being programmed to 10 volts DC from a power supply. With our initial settings, we start the motor. And then the system begins decelerating the motor. Now in this case, the red line did not touch the blue line, but it was fairly close to it throughout the whole adjustment range. That is not ideal response, so what we want to do is increase the I term. We'll go to the next scale of B and run the procedure again. Now in this case, just changing the scale gave us a very nice adjustment. There is a small amount of what is called a jerk at the start of the ramp, but the red line comes in and lays on top of the blue line for the rest of the way down, and this would be pretty much an ideal adjustment. It's not necessary to remove this bump at the start of the ramp. In fact, if you continue to make adjustments to remove this, you'll find that you've overcompensated and your system will probably become unstable down at the lower speeds. To show the effect of going too high on the I term to try to remove this bump, I will increase the scale and run it again. Now you can see immediately that the system has begun to oscillate, and it gets very bad once you get into this range, and this is an unusable setting for the tuning adjustment. If we go back to the B scale, you'll see our system response is nice and smooth. In some cases, it might be necessary to use the dynamic P and dynamic I scaling if your dynamometer controller has that feature. What the controls do is change your P value from the full setting that you have selected to a larger or smaller value when you get to the bottom of the curve. Sometimes the motor will be nice and stable at the beginning of the ramp and unstable at the end. In that case, you could take your dynamic P or your dynamic I scaling and reduce it, and then the value of the P and the I terms will be the greatest at the start of the ramp and will be reduced to the smaller value at the end of the ramp. Putting a value of 0.1 in for the control causes 100% at the beginning of the ramp and 10% of the value at the end of the ramp.